In this video, I will show you guys how to create your own differential equation that requires a specific substitution in order to solve. And you will be the one who knows what that substitution is. So check this out, it's going to be really cool. So first, I want to just put down my derivative on the left-hand side, and let me just put down the v dx right here. And I'm going to think about it. I want to think about how do I want the people to solve this right here. And just make it something easy, okay? And if you have seen my previous video, this is what I did. I start with dv dx, and I'll make this equal to 1 over v squared. So as you can see, this is solvable by separating the variable, right? I can just multiply v squared on both sides and multiply the dx on both sides, so we can just integrate both sides. That's pretty much it. So that's pretty much, you start with an easy enough differential equation in terms of v. And if you want, you can put on some x right here on the right hand side as well. And just have to make sure this right here is easy enough to solve. Maybe by separating the variable, or maybe by the first order linear differential equation, the integrating factor, things like that. Okay? All right, now this is v, and you want to decide whatever you want, all right? So in my previous video, I left v equals to whatever you want in terms of x and y. Of course, keep it reasonable. And I chose to do x to the third power plus y to the third power. And seriously, right here, you can do whatever you want. You can even do sine of x times y inside like this. But this is it. I left v equals to x to the third power plus y to the third power. And then next is that I will look at this differential equation and differentiate both sides. And keep in mind, v is a function of x. Y is also a function of x. Okay, keep this in mind. Okay, so on the left-hand side, I differentiate that. I get dv dx, and this will be 3x squared plus, this is going to give us 3y squared dy dx. And you see right away, we have the dv dx, right? So now I can just put this to that, and we will have 3x squared plus 3y squared dy dx. And this is equal to 1 over, here I have the v squared, right? But v, I set it to be x to the third power plus y to the third power. So I'm just going to open the parentheses and put this right here. X to the third power plus y to the third power, and then square, like this. As you can see already, right? This is now a much crazier looking differential equation. At the end, I just had to isolate the dy dx, and then I can present that to people and have them think about how to solve and things like that. Anyways, let me finish that for you guys first. So let me minus the 3x squared on both sides, and you will have 3y squared dy dx equals to this on the left-hand side. On the right-hand side, it will be negative 3x squared plus that 1 over x to the third power plus y to the third power, and then square, right? Well, I want to keep my dy dx clean, so let me just go ahead, divide everything by 3y squared, and this is my y, and then divide this by 3y squared, and divide this by 3y squared, so let's put it down like that. And you see that this and that will cancel. We will have dy dx. This will be 3 and 3 cancel, so we have negative x squared over y squared. This is my square. And we add it with 1 on the top, right? 1 times 1. And then we have this 3y squared times x to the third power plus y to the third power, and then square. And ladies and gentlemen, this right here is a very crazy looking differential equation. And the way to solve it is to let v equals to x to the third power plus y to the third power, because we designed it to be like this. And of course, once again, you can start with any easy differential equation, right, in terms of v, and then let v is equal to whatever x and then whatever y together, and you can create your own differential equation that you will be the person who knows what that substitution is. That's it.